While we're waiting for everyone to join, Mark, I've got a quick question for you.
Absolutely.
When you're when you've done testing, what kind of utilization have you seen as kind of the max on SATA SSDs from a nearing the maximum throughput that the devices can hit?
So like on a SATA SSD with like Blue Store and like what kind of IO workload?
Uh, doesn't matter. Let's say a large sequential. We'll start with that.
So on the read side, I've seen us hit a little higher previously than on the write side, but it can depend on a lot of factors and kind of what the underlying IO looks like, right? Is this Sorry, I mean, I pepper you with more questions, but in this configuration, would there be an SSD journal, or would it just be everything going straight to the hard drive?
Yeah, everything's on the SSD. It's all on the same device.
Oh, sorry, SSD or hard drive?
SSD.
Oh, SSD. Sorry, I thought you were
Yeah.
saying hard drive. Okay, on an SSD setup, you can do pretty well, depending on what it is. If it's like able to deliver super high IOPS, we won't hit it. Well, you'll probably stall it on CPU first. If it's kind of a more typical, maybe like able to do 20 or 30,000 write IOPS, for like a SATA 3 type device.
Yep.
Um, you can probably do closer, but then it depends on how well that device can actually do like OD sync writes and
Right.
other things like that. So I guess the answer is that it's highly dependent on exactly what the device is capable of and kind of sometimes some non-obvious things like what how well it really handles sync writes and
Yep. Yep.
other things. Um,
Okay. Well, that's good info. I've been doing a lot. Still continuing this stuff I've been doing all year, and I'm at the point now where I feel like I'm getting close to the threshold of what I'm going to get um, with the Luminous code I'm using. So now it's
oh yeah,
it's
Luminous
gearing
is
us
pretty
up for
old.
some of the stuff. Yeah, gearing us up for some of the stuff we're you're talking about today, right? So it's wonderful.
Yeah. Um, there are some improvements in master right now, depending on if you're talking about RBD or RGW or whatever. You know, both have improvements that are probably going to improve things at least somewhat if you're using high-speed devices. Um,
Yeah, most of
Really
my
though,
workload is Ceph, which I have to say I'm quite impressed with our ability to drive performance. So
good,
yeah,
good. And
when
actually,
I wrap
Ceph,
it up, I'll share some results with everybody so we can see because my intention is to finish up the work on Luminous and then flip it to our Nautilus code base and do a comparative there.
nice. Yeah, definitely. Just let me know if you want to present at the meeting here, and I can, set you up to be the kind of
Yep,
main presenter.
certainly.
All right. Well, let's see. Let's move forward here. Sage just told me he can't make it, so we'll just go ahead. There has been a lot of work going on in the last 2 weeks. Lots of PRs, new PRs, lots of PRs closed, lots of PRs updated. So I'll just kind of quickly go through some of these. Um, let's see. Eric started working or has a PR here for uh, implementing more filtering in the CLS code inside the OSD for bucket listing rather than sending a bunch of extra entries to RGW and then have it deal with it. So this, in probably most respects, should be much faster. The only question I raised in the PR there is whether or not just an observation that by doing the decoding and then re-encoding things at the CLS layer inside the OSD adds a fair amount of extra overhead. Um,
Right. I
It
just
may.
responded to your comment to the PR, and my filtering only looks at the key. There's a map of key to some sort of directory structure. It doesn't actually need the directory structure to be decoded. I believe from previous conversations that maybe other filtering that's done might require the decoding of the directory structure, directory entry structures rather. But mine does not. So it's completely orthogonal to your PR, except for the fact that fewer things will be sent back. It'll limit even further the number of buffer lists you send back to the RGW.
Cool. That's exactly what I was hoping you were going to say, Eric. So I don't know if we want to do my PR because it's kind of I don't you could kind of think of it as a little hacky, I guess. But something like that maybe we do want to do. I don't know. We'll see. But cool.
Yeah.
That's great, Eric.
Yeah, I would love to measure the benefits, the performance benefits, both in terms of maybe network usage and CPU usage for encoding, decoding of my PR. I'm not sure exactly how best to target that. I don't know whether you have any advice on that, Mark.
I have been for the stuff that I was doing, I was just looking at like wall clock profiling of how much time we're spending in it. I wasn't even bothering to look at like, the network traffic or anything else like that. Just, what is where are we spending time? Um,
Right.
but
Uh-huh.
yeah. So you could use either my wall clock profiler or Adam, his wall clock profiler that he wrote. His is faster than mine. It's using libunwine directly and a bunch of like assembly code, but it's just a little harder to get up and running since mine
Okay.
is basically like Python with GDB, which is as long as you've got debug symbols, it basically works.
Got
But
it.
it's slow.
Yeah. Yeah, I think just to get rough estimates, I'll just use yours. Sounds like it's a lot easier to get. I've actually used yours in the past, so
Oh,
yeah.
cool. Yep. Um, all right, cool. Yeah, that's exciting. All right, let's
Yeah,
see what else
the
we got here.
sorry, the
Oh, go
the
ahead, Dave.
performance of the filtering stuff is going to depend a lot on what all your object names look like because it's the delimiter and prefix searching, the filtering that's moved down. So if you don't have like nested directory names at all, then it won't have any effect. But if you have lots of nesting, then it'll have a big effect.
That's true. Yeah. In
Yeah.
fact, my code only activates if a delimiter is sent. If the delimiter is not sent, then my code has no bearing on anything.
Yeah, it sounds to me like we probably want to at least be doing the decode step in the CLS code so that we can do your filtering plus all the existing filtering we do there, plus potentially new stuff. I guess my question would be more of whether or not it's worth actually decoding and re-encoding the actual like entries, right? I think yours doesn't. Sorry, we're not. I think we could still send the encoded entries. I guess that's maybe more it, right?
Right. Yeah. In fact, yeah. Again, mine doesn't even need to decode the directory entries. It just looks at the key part of the map, which is the identifier. So
Yep. Yep. So I think anything that we're doing like that definitely seems like it's probably worth it. I guess I would just be more concerned whether or not if we're doing stuff with the value portion, maybe. Well,
Casey, I
cool.
thought you
Sounds
mentioned
good.
that there's some code maybe in CLS which does need to open up the value portion. I I didn't look for that specifically, but is that the
Yeah, there's a couple things that filter out based on the flags field of the directory entry, and that's specifically for versioning. If it's not a current version, or if it's a delete marker, I think, and you're not requesting a versioned listing.
Casey, do we actually need to re-encode it, or is it good enough to just decode it, grab the filtering, or do filtering based on those things, and then send the original encoded version? I think that's what my PR does, isn't it?
Yeah, you don't have to re-encode it.
Yeah. So I guess at least there's that, even if we are decoding the actual entries themselves or the values themselves.
Yeah, Matt's objection to doing this was more from like an API perspective. Like DLS clients don't really know what to do if they're given a bufferless blob. So there's advantages to having the actual structure there for the client. Um, but we might be able to do some hacky stuff on the sending side so that it sends a buffer list, but the client knows to decode as a structure. But yeah, it gets a
Sure.
little messy. That's all.
Sure. With some of those things that you mentioned that are in the values that we filter based on, if we kind of reorganized it, I think you had maybe even mentioned this before. Do you think we could avoid doing that decode step on the actual value?
Yeah, yeah. If we split the flags out and just had a separate buffer list.
Yeah,
But yeah, I don't know if
might
we
be.
could do that and kind of leave the client side unmodified.
Yeah, maybe if you had them in both places, if you duplicated it and then just grabbed them from the other thing that you had. I don't know. Well, anyway, anything more on that, guys?
Nothing for me.
All right. Well, we got a pile of these things to go through, so we'll get through them here quickly. So there's this one from Igor about fast automatic legacy status fix. Anything there, Igor, to discuss?
No, well, actually, that's mostly not about performance, but about automatic updates to fix legacy stats.
Sure.
But it has some
Okay.
improvements in regular FS check as well.
Cool. Okay. Let's see. There's this re-implementation of test slash perf local for adapting for ARM version 8 fixes and make that work apparently. There's this inline immutable small object with onode. I think we should talk about that here later. But basically, this I think originally started out as a PR to RGW to put small RGW objects into OMAP, which then kind of morphed into well, we're thinking about switching or shrinking the min-alloc size in BlueStore, and then also he wrote this PR, which is also somewhat similar to one that Igor wrote a little while back that does something similar with putting small objects into small Rados objects into either the onode or into OMAP or whatever directly. So anyway, yeah, let's talk about that after we get done with all these. There is a mutex contention optimization in the throttling code. Greg looked at it and gave it a thumbs up. I have not looked at that yet, and I have not looked at that code a whole lot, so I'm going to have to be able to study it a little bit before I can give any updates or advice on it. But the one thing I did ask Majian Peng for is data on whether or not it actually is showing any lower contention or not. So let's see, those are new PRs, closed stuff. Niha has a couple of QA suite PRs that merged. One is for testing a 2 gigabyte 2 gigabyte OSD memory target size. The current minimum is 1.5 gigabytes that she was testing, and there's some really nasty performance during OMAP deletion that she was seeing with that. So I'm just curious if we set a 2 gigabyte memory target, if we still see that, since larger ones were working fine. Might be a caching related thing, just thrashing stuff because there's not enough. This other do not sim link to QA, I don't actually even know what that is. It was tagged with performance, but yeah, I'm not sure about that. There's this one from I'm gonna mangle the name, but Shaishin Guo maybe, about the Blue Store BlueFS Max Free size, adding that. This was just, from what I recall, looking at it, dealing with some of the a bit of fallout from Sage's PR to change the BlueFS Alex size to be smaller. I think by doing that, we essentially made it take longer to do allocations in some cases, if I remember right. So anyway, that apparently merged. I think Sage had reviewed it. And maybe, Igor, did you review that as well?
Yeah.
Okay, cool. Let's see. Messenger version 1, avoid unnecessary bufferless swaps. Got merged by Kifu. This read v one, Sage was looking at that. That got merged. I think that was a redo of another older PR. My removing get val from the hot path and RGW got merged by Casey. The other version of it I had got closed. The older version of this perf local arm thing got closed. Dumping JSON from the hot path during reshard, that was mine. That got merged by Casey. And then Casey's one to avoid doing these reshard checks during the right path when you are going to eventually do a reshard. You already know you're going to, but you haven't started it yet. That got merged, and that's a big performance win. This beast parse buffer size, that got merged. The other one about read data portion of pushing object in batch. I don't remember which one that is, but apparently it merged. Let's see, Adam's aging test for Blue Store allocators. That was kind of a long-standing PR that he had started like almost a year ago, I think, and SageOne kind of had reopened. That got merged, and then this new op queue, we had requested performance data on it and never heard back, and that eventually just got closed by Stillbot here. And then updated PRs, some stuff for Rados Bench. I had looked at it and generally gave it a thumbs up. Kifu looked at it and had a couple of nits that he had noticed that I hadn't. So that is those things are being fixed and is in testing. Igor's, I think your version 2 intelligent DB space usage thing, looks like you maybe made some updates to that. Is that pretty close, or is that in good shape? I guess it still did not merge.
Well, it doesn't have DNM and RFC labels anymore. So,
okay.
yeah, it's in a pretty good shape. So ready for review and probably match.
Cool. Let's see, Sam's stuff for LTTNG trace points and FIO Ceph object store backend. That just needed a rebase last week or the week before, and he did that, and now it's back in with Kifu testing. See, this finisher one failed testing, so that's back into needing work again. iObject got updated again, I think. The MDS cache memory limit based on RSS usage, that's continuing to get updates. I think it at one point needed a rebase, and now it's just getting more review and more updates. Adam's sharding work, it's looking really good, except for one small problem is that rarely it's showing a segfault is coming up after about 8 hours, 6 to 8 hours worth of workload thrown at it. Briefly, we were worried it was from my my older cache refactor work in Blue Store, but Adam, thankfully for me, showed that it was not that, and is happening even on an older master prior to my change. So he's working feverishly trying to figure out what happened or what's going on. So for now, we're stuck on it a little bit, but hopefully soon he'll figure it out and we can get this thing merged. Let's see, there's a PR from Majian Ping about narrowing down locking. I was going to try to take a look at that, but I do not feel comfortable at the moment making judgment calls on the locking part and that code, so I'm going to need to do some reading first. And then, Adam's other objection sustained PR, I think got updates as well. So that's
so many updates.
Yes, so many updates, Adam. Anything interesting?
Basically, currently I'm just sort of massaging the rest of RGW back around the changes. As far as iObject goes, I just need to run that through testing through the non-RGW subsystems, and then, go around and beg some kind spirit to give me an approval.
It's a big PR. Those are always the scary ones for me, at least.
Well, yeah, if we think it's ready, it would be better to kind of merge it and get some more bashing on it before we're too scared to merge it for Octopus.
Yeah, basically.
Yeah. I'd say just bite the bullet, get it in, and hopefully we don't break anything too badly, but we'll see. All right. So that's all I had for PRs. Thankfully, that was more than enough. I was thinking, unless anyone has anything else they would like to discuss first, maybe we could talk about Casey's RGW bucket splitting proposal to avoid write stalls. Anyone have anything else they want to talk about before that? All right, Casey, do you want just kind of give a real high-level overview of kind of what you were thinking?
Sure. So the current RGW bucket resharding involves kind of lacking the bucket while we do the reshard, so clients can't write it in the meantime. And we would like to find a way to not block all I/O. And so I proposed a way to effectively allow clients to write to both bucket indexes during reshard. And tried to highlight the races around that need to be solved for that to work. One thing that it can't handle is versioned buckets, which is unfortunate.
So I saw that Yehuda had replied and had mentioned kind of doing something sort of similar, but not exactly the same. Did you see that?
I did, yeah. Seems quite a bit more complicated. Haven't fully digested what the right path looks like in that case. So yeah, it effectively splits the resharding into two steps. Like while you're copying entries over to the target shard, you're still writing to the source shard, but you're writing to a separate, he called it an overlay. And then once all of the non-overlay entries are copied over, you transition to writing against the target shard. But before you can write, you have to check the source shard's overlay to see if something changed since the reshard. And that's the part that seems kind of expensive, extra round trip to pull the source shard. And I'm not sure exactly how that works with versioned objects needing basically multiple OMAP keys. But yeah, that's the difference. If it can handle versioned objects, then that's wonderful. But yeah, the extra round trip on writes is not quite as good, but it's definitely better than blocking all I/O.
So presumably, writes would only be blocked for a shorter period of time while the overlay is transferred to the target. Is that the correct understanding?
Yeah, I forgot that part about how the overlay gets transferred over. But I don't think the design implied blocking the target shard while you were doing that. I think as long as writes to the target shard first check that overlay and apply changes there first, then you can do it without blocking.
Okay. I remember I'll have to reread Yehuda's email, but I thought he said stop writing, but maybe that was when the transfer took place from the source to the target. So I'll have to reread that again.
I have to say, when I was reading through Yehuda's proposal on it, it did seem really complicated to me. Like I also I think need to reread it again, maybe possibly several times to really uh, to get the whole picture of it.
Yeah, it's kind of one of my earlier ideas for this was to do some kind of like journaling or logging on the source shard of changes that happened during reshard, so that after reshard you could replay those, but that replay step would involve blocking.
Sure. So in any of these, I guess one of the things that I was wondering is in the email I kind of sent out, I've been kind of thinking about whether or not we could do something where we work in smaller chunks rather than like whatever we decide to do at this level. Kind of, could we have at kind of like a higher level, could we do charting based on not on like a hashing scheme, but instead just like based on the value uh, of the name, an ordered value of the name. So I don't know if did you see that? And we talked offline a little bit, Casey, but did you see the email I sent out?
I did, yeah.
And
Yeah,
I read
and
that. Yeah.
the ordered partitioning sounds a lot like what Eric is going for, but it does add kind of sharding within those partitions.
Right. So if my
So
understanding
Eric,
is there are blocks, sequences of blocks throughout that sharding space. But within those blocks, things might not necessarily be ordered. Is that a fair understanding?
so the thought I had was basically we kind of almost implement whatever we're talking about implementing here right now generically is kind of what you end up just putting inside one of these groupings of or blocks of entries. So if we've got entries, let's just say numerically because it's easier for me to think about it that way. 1 through 20 or whatever, and then 20 through 40. Within that we do some kind of hashing or round robin or whatever scheme we come up with that potentially could block or not block, I guess as the case might be. But then we potentially can avoid locking the entire bucket when we split one of these pools of shards that are grouped together. Does that kind of make sense?
Yeah. So you're sorting at a gross level, but then at a fine level, you're not sorting. But it simply reduces the problem. So when you're listing, you're only looking at a small segment of the entire shard space. Um, and likewise, when you're resharding, well, actually, the resharding is now done like through a splitting mechanism as opposed to redoing everything, right? You
Yeah.
would take,
Yep.
yeah, uh-huh.
Yep. You'd only say if you have entries 1 through 20, and you're ending up with more entries in that range. Now all of a sudden maybe that splits into 1 through 10 and 11 through 20 or something, right?
Exactly,
And
yeah.
that thing gets locked, and those shards get split that are participating in that pool or that grouping. And that can happen whatever mechanism we choose to do that splitting. I don't know what it is. Maybe it's the same one we use now, or maybe it's something more advanced or good that we come up with. But the idea is that then you don't lock the entire bucket to do it.
Right. So one issue that we face is the metadata to describe a bucket's bucket indexing scheme can't be too large. So like that would definitely work if we had maybe hundreds of those segments, possibly even thousands of those segments. But like whenever you get to the bucket, you're going to have to load in what those splits are from metadata. And we don't want that to be too large because otherwise that metadata starts dominating certain processes. So that's something we want to think through on a scheme like that. But it sounds like they could be a middle ground. We're not segmenting everything because within those segments we're using an existing, say, hashing scheme. So that's something that
Yeah.
we think about too.
Yeah, it could even be something as small as a byte, right? You have 256 entries, split positions, and then you have maybe each one of those can be at different different places, I guess. So you could keep it pretty small. Maybe you want bigger than that. Maybe you want more, but
yeah, we also have to allow for very large object names. And so if we're splitting on object names, an object, these things may be relatively large. They may be representing a directory structure with delimiters in there, and we're splitting at arbitrary points, presumably. So the split point could actually be represented by 1,000 characters, 1,000 bytes, right? If we're splitting between /XYZ/ABC/ blah, 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 unless you had some extra logic in there to try and find optimal splitting points that the names would be shorter, higher up in the directory structure if we're kind of mapping our names to that. Does that make sense?
Would we need the entire name for that splitting though? If it's kind of coarse-grained?
At arbitrary points, or whether we try and split at. It depends on what that namespace looks like, because it could be that everything in there has the same 100 bytes at the beginning of the name, and only
you're right.
You get the 101st byte. So.
Yeah. Yeah, you're right. In the worst case scenario, you could end up with something like a prefix that everything's in the same prefix.
Hey, sorry to interrupt. Are you suggesting that we fill up one shard up to the shard threshold and then overflow onto the next shard once we've crossed the threshold and so on? If the threshold for each shard
except I think it's splitting rather than going over to the next one. So if you fill one shard, you would kind of split it in half and recursively split.
So do we even need to do that, or can we just? Do we even need to do that, or can we just fill up one shard up to the threshold and then always start with a shard number 0, and we can always keep creating newer objects with .1, .2, .3, and so on. And sharding is like automatic and incremental and progressive.
Yeah, so we're trying to solve like two big problems in RGW with these various proposals. One is that currently listing is ordered, and that's a very expensive operation because the hashing scheme entirely jumbles up the order once it reaches the bucket index. And in order to return things in an ordered fashion, we have to consult every single shard. Even if there are 65,000 shards, we have to consult every single one and say, give us your first N, give us your first 1,000, or give us your first 100. And we have to go through those and then find what are the first 100 or the first 1,000 of those and return those back to the client. And we have to keep repeating that process again and again. So the hashing scheme for bucket indexing is ideal. It's very fast. It gets us to the right shard immediately in every operation with the exception of bucket listing, which is ordered. And so we're trying to solve that problem, and in parallel trying to solve the problem of we have to do a reshard, not locking the whole bucket for that process. So That's what we're trying to do here.
Yep. I, that's really good summary, Eric.
Uh, mm, yeah. Please go ahead. I'll just consolidate my thoughts.
So yeah, I just wanted to bring up the MDS because they have the Durfrag tree thing, which is a very compact way to represent splits, but it splits over the hash space. So I don't think it really applies here.
Casey, you had mentioned offline to me that you guys had some kind of idea about um, using like Fourier transforms or something. I don't remember the details, but what was that?
Right, yeah, I'll let Eric talk about it.
So the idea is that we would probably use something like your original scheme, where we're taking a gross cut at the namespace, and maybe dividing them into segments, because there are very likely gaps in the namespace. So there's like a cluster here with a similar prefix, a cluster there with a similar prefix, and so forth. The first step would be to kind of do a very gross, maybe on the order of 16 different segments within there, and we can scan it to see what those optimal segments are. And then to describe the distribution within each of those segments, somehow with a function that we could represent compactly, because again, we want to keep this metadata representation down to a minimum. Describe it with a function that we can then integrate, and then we can that would allow us to basically plug in the name. And it allows us to provide a function such that we can plug in the name and tell us which shard within that segment that goes to, while maintaining ordering throughout that entire space. That's kind of the idea. And with Fourier transforms, you just have to maintain a set of coefficients for various terms within that sequence there. And so that would give us the compact representation and a fairly quick calculation. The expensive part is determining how to segment those things up and how to determine what the coefficients are for the Fourier transform. But that actually can be a slow process. We can spend spare cycles figuring out what the next sharding scheme is going to be, what might be optimal for it, and then once we decide, then we can implement it, and that part can be fast as long as the lookup is also fast. So that's kind of the basic idea. It takes some of the very ideas that you proposed, Mark, and then tries to figure out a nice way to maintain the ordering within the segments through a compact representation.
Okay. How would locking work in that scenario?
Well, one nice thing is that if we ever do a reshard, we could do the resharding in lexical order of the object names, and we could only necessarily have to lock the portion of that namespace that we're currently working on, because before you reshard and after you reshard, the ordering of all the object names is going to be the same. So we can, lock down A through J, and K through Z doesn't have to be locked at all while we're doing the resharding and resplitting of that piece of the segment. Does that make sense?
Okay.
So
Okay.
the thing is, with hash space sharding, there's no real mapping between the old sharding scheme and the new sharding scheme. Things get mixed up entirely across all that. So it would help, at least in that respect. But I still think we need to be able to reshard more efficiently in the current scheme. Because in some cases we may resort to the current scheme too. So.
Okay.
Yeah, Mark, that's what I was talking about when I mentioned the sliding window for reshards.
Yeah. Do you guys want to talk about that a little bit too? I don't know whose idea it was, but
I believe it was Eric's idea, but honestly, I still favor a strategy where we don't block, and I think the one that I presented is general enough to handle any resharding scheme as long as it's kind of a full all shards to all new shards scheme rather than kind of just a local split. Yes.
Casey, do you think that the there's going to be how bad do you think that that double write penalty will be for writing to both buckets?
Well, assuming that
Not
they're
sorry,
on,
shards.
yeah, assuming that the shards are on different OSDs, we can do the writes in parallel, and so there shouldn't be much overhead.
It's it's not a full copy of the data, right? It's just the metadata, or is it the a full copy of the data?
Resharding is just moving bucket index entries, so it's a single OMAP key
Yeah,
generally.
yeah. So it's just doubling of the metadata rights for the
Right.
bucket index
So
information. Yeah.
so the bucket index transaction is a prepare app and then a complete app at the end, which is async. So we would have to
Yeah.
send two of each.
So I mean, we hit the RocksDB a little harder, but you know, it'd probably be non-negligible for really tiny objects, but you know, it might not be too bad. Casey, do you think we can combine that technique with either, you know, what Eric was talking about with the Fourier transform idea, or kind of this other, you know, maybe you know, more tree-like thing that I came up with?
I think so, yeah. I mean, all it really depends on is being able to place the current object on the old sharding scheme and the new sharding scheme. So as long as you have a function to place it on both, you can write to both.
Okay. And then even on the versioned case, if we did something else like that, you could at least still make the blocking cheaper with like Eric's scheme or the thing I came up with, because in this the version case where you still have to block, right, with yours.
Right.
Cool. Well, maybe that's the way to go then. I don't know.
Yep.
Well,
I don't
anything?
I
Any?
don't quite know at this point either, but a lot of good ideas out there. I think I might wait a little bit to see how Eric's new index scheme works out, and if there's anything special about resharding there that this design doesn't cover.
Eric, are you working on that now?
I am. So I worked on it a lot, like in 2018. Then a bunch of other stuff came up, so it kind of went on the back burner for a bit, and now I'm bringing it back up again. So I've been collecting like a corpus of, or rather, according to Ad, I think the plural of corpus is corpora apparently. So a corpora of object names that are actually used in the real world. I've asked people who posted the things like Ceph users and said, why does bucket listing take this long? And I said, can you send me a list of your object names so I can, start playing with things and writing some code to do the segmenting and calculation. And I think ultimately, I don't know whether Fourier transforms is the correct integratable function to use, or we might have like a small menu of them and see which ones fit the data the best. So that's kind of where I am right now, is trying to figure out, because we can spend much time figuring out what the optimal thing is for the current list of object names. As long as once it's determined, we can chart it quickly and figure out which chart to go to given an object name quickly. So anyway, that's where I am now in that process.
Cool. That's exciting. Well, yeah, very much will be interested in seeing what you come up with.
I need to drop for the RGW stand up. Thanks, Mark.
Oh.
Bye-bye.
Okay, yep, thank you. All right. Well, then, if you guys have to leave, let's wrap that up. The only other things I had here are the Blue Store 4K min Alex size and small object and OMAP stuff. So Igor has been doing a lot of work looking at hard performance on hard drives of 4K min Alex size, and I guess Igor, you were saying that you were rerunning some tests to get write cache out of the picture, but it sounds like it's still faster with 4K min Alex size generally versus 64.
Yeah, looks like it's still faster for small block sizes. But I haven't completed all the benchmarks I did before. And also I haven't done any benchmarking for large block sizes. So a bit too early to say if we should migrate to this setting. I mean lower min block size.
So I might try to replicate some of your hard drive experiments on one of the Incerta nodes. Just since I've got some of the NVMe tests there, maybe I can see if I'm seeing the same thing you are on hard drives. But if it holds true, I think we should maybe do it. We've got some people that are apparently now doing small objects in RGW, and it's going to be a really big problem if they have the kind of space amplification that it's causing, I think. Even if it's a little slower.
Yeah, definitely.
Josh, do we have any idea or criteria on how we'd want to rate space amplification versus performance for stuff like this?
That's a good question. I guess one aspect to consider is also like the impact on especially large stores. I think you had a comment in there on the PR. I think we've seen particularly problems with very large databases, and so I'd be kind of wary about stuffing more things into the database potentially, and perhaps hitting those problems sooner. So I think we would want to do a lot of testing with like small object sizes to at large database sizes.
Sure.
Including the charting stuff from Adam too. That should help a bit, but I'm just a little bit wary of it, of increasing the database size by a lot. Because if someone has a workload that's writing like tons and tons of 1K objects, that's basically putting all the data in the database.
Does it actually change the amount of data in the database with a small min Alex size if the object size is that small?
Oh, sorry. I thought you were talking about the other patches to put small objects in the database directly or in the O node.
Oh, no. This right now just the 4K min Alex size.
Okay. Yeah, the min Alex size, no, that's not worried about that at all.
Okay. Yeah, I mean the trade-off would be potentially if we did see lower performance, in some situations, kind of how we judge performance versus the space amp reduction by doing the smaller min Alex size.
Yeah, I think you have to kind of look at it on a case-by-case basis. Like, is this like a really common scenario? And what's the extent of the performance impact?
And I don't know. Do you know, or I mean, are we starting to see more people doing like really small objects in RGW or like directly with Rados?
RGW, yes. We've seen a lot of users do lots and lots of small objects, even like smaller than 64K or 32K even. So I think 4K object size will help a lot. Min-alloc size will help a lot with those folks.
Okay.
And from the performance results I think we've seen from you and Igor so far, I wasn't too concerned with the min-alloc size changing.
Sure. I guess given that, and given kind of what Igor's seen so far and what I've seen, I'd almost kind of like to maybe just get it in right away so that we've got some testing under our belt for Octopus.
Yeah, that seems reasonable to me.
What do you think, Igor?
Yeah, this makes sense. Well, maybe general comment on all this stuff. Probably we need some, well, a standard benchmarking to validate regressions by changes like that. Right now, as far as I understand, we don't have any means to detect any performance regression other than by manual running stuff.
We do have some automated tests that are running right now in Teuthology as part of like the Rados suite that might pick it up. And then the stuff that Kipu is working on for running tests as part of like a Jenkins run. We're actually migrating a bunch of our test infrastructure over to do that once we've got things a little farther along, taking longer than we wanted. But that is being addressed, Igor, to some extent anyway.
Mm-hmm.
The tricky part though is that, you know, depending on what you're doing, right, an automated test might not pick it up. You're at least in my opinion, you're usually better on anything that's really targeted like this, you know, writing a test that's kind of designed to hit the cases you'd expect to see performance regression. But I don't know. That's just my take on it. I think the automated testing is good for catching kind of high level stuff, but maybe not you know, specific things. Any dissension on that one, or any thought on that one?
Well, what I'd like to have is a sort of library for some access patterns that we expect are commonly used and benchmark these patterns.
Sure. There was a case where we did something kind of like that, where we there was a customer that had two different brands of SSDs that one was showing poor performance and the other wasn't. And we were able to record with block trace the actual I/O pattern going to the disk and then replay it on one brand of NVMe and then the other brand of NVMe drive, and showcase that even if you took the workloads from each and swapped them, the one still was bad. Maybe we could do something like that to even be able to test things, you know, different you know, workloads, I guess, hitting some of the underlying layers. We could do it at that layer, or we could do it a step above, like a Rados, maybe workload hitting an OSD or something.
Well, anyway, I understand that's not a question we can answer immediately, just maybe some topic to think about in future.
Sure. Yeah, it's a complicated one.
Yeah.
Okay,
But
so
indeed, if we like to change min-alloc size, it makes sense to do that as early as possible before the Octopus release, to have some time to verify how it behaves.
right, cool. I know you're going to be on vacation for the next 2 weeks, so I'll try to see if I can replicate some of the stuff you were doing and just see if we can get a PR going and merge it. I'm pretty comfortable about of how it looks right now with NVMe drives. So and really like your testing seems like it's already showing, even with the write cache disabled, it looks like it's still faster. So I feel pretty comfortable about it, but I'll try to see if I can get some replication of your results just to make sure. Okay,
Yeah.
small object.
Okay, so just to say that additional independent benchmarking would be nice to see the results for this independent benchmarking. That's it.
Yeah,
Cool.
Igor, I'm going to take a run on my SSD cluster. It'll be with Luminous code, but I'll make that change and evaluate it there as well.
Yeah. Well, actually, I saw some difference for Luminous as well. So probably if it's in Luminous, try to lose it.
Yeah.
Good as well.
So the only other thing quickly here I wanted to bring up was small object in OMAP. And Igor, you've got a PR that does that, and or I guess in the O node is what this other one does. Any thoughts on doing this? I have some concerns in general with it, but I think Josh, you mentioned you had concerns too with large databases, which is my concern too. But any general thoughts on this?
Well, what I'd like to say is that probably we shouldn't concentrate on performance only in this case. So this feature looks pretty beneficial for users who don't need much performance, but they care about the space of the drive. So even if it brings some performance degradation, it might be useful, and so it might be optional. So one can enable it for when space is more important than performance.
Yeah, that's a good point. This feature is nice in that it doesn't require, like it could be enabled according to some criteria at runtime or disabled at runtime. Wouldn't require any kind of layout change on disk.
What happens, I guess, when you enable it? It's not going to immediately fix anything, right? It's just going to be for new object writes.
Absolutely.
So you'd still either need to redeploy the OSD or have some kind of conversion process if you enabled it after a while, I guess.
Yeah, that's it. But well,
We always have
I
the
doubt
option
there
to
is
redeploy the OSD.
any good. Just go ahead.
You can always redeploy the OSD to take advantage of a new thing like this being turned on. Just let backfill, copy all the data.
Josh, do we have anyone doing like that small of objects in RGW, like smaller than like a 4K size?
Definitely yes, but I'm not sure how high of a percentage it is. I think we've seen more commonly like 4, 8, 16K. I could go check in some of the corpses we've seen before. Might be interesting.
I mean, it almost seems to me like if you're doing it that level, you'd almost want to like use some other mechanism to like a distributed database or something. But maybe I'm not thinking about it right. I don't know.
Well, yeah. I mean, storing objects of this size in S3 certainly is inefficient, but I think we can't really stop folks from using the interfaces in ways that are inefficient, right?
Yeah. No, I'm just wondering, like, does it certainly, and you can do this right now in RGW, right? There's nothing preventing you. In my mind is, are we trying to optimize for something that's crazy? I guess, or not. Maybe it's not crazy.
Well,
Yeah, I
I
mean, you could,
recall at least 2 or 3 attempts to keep pretty small objects in Ceph. Well, they were not less than 4K, but around 9K, and keeping that for spinners with 64 min-log size has pretty much right amplification anyway.
Yeah. I guess what I'm wondering is with a 4K min-log size, if we can switch to that.
Yeah, indeed, this will change things dramatically. But anyway, if you have object sizes unaligned with 4K and object size is pretty low, like 9K, your right amplification is pretty high, so you might lose up to 3K per 9K object, and around 33%.
Yeah. Yeah, and I guess I don't know or have a good sense of whether or not, when you're dealing with objects that small, how reasonable that really is or not.
that is comparable to local file systems, at least, where usually block size ends up being 4K, right?
Yeah. Well, anyway, I guess we're out of time for today. We're over 11 o'clock, but maybe things to think about. I guess my take would be let's get the 4K min-log size in first, and then maybe figure out where we're at after that. Any objections?
I think that's good stuff regardless.
Yeah, that's a good starting point. But again, as I said, having this feature to keep small objects in RockDB, I mean optional feature, it probably has no drawbacks. If you don't need, you don't enable it. We can not enable it by default, but for those odd users who want it, please enable and
Yeah, that might be a reasonable way to put it.
Could also be that the bad side of it, or the impacts of it, are much better once Adam's charting work is done.
Yes, that may be true too.
All right. Well, let's wrap it up for today. Anyone have anything else they want to touch on before we finish? All right. Well, have a great day, guys. I'll see if I can get some of this 4K min-log size stuff done so we can get a PR for that going and merge it, and then we'll see everyone next week.
Thanks. See you next week.
yeah, see you. Bye.
Have a good day, guys. Bye.